Welcome to Kerbalism. I'm your host, Aubrey Goodman. In this episode, we'll review the basics of deploying a satellite to low orbit. Let's get started. Long before we think about sending people into orbit, we need to send smaller unmanned probes. These serve as opportunities to learn about the perilous environment of low orbit. As we'll show, they also present a solution to the issue of communication within the solar system. Without relays to boost the signal back to the original planet, probes must carry heavy radio hardware, powerful enough to reach home. Heavy things cost more to send into orbit. Lowering the cost is often a matter of reducing payload mass or using fuel more efficiently. There are many things to consider, even when designing a simple satellite deployment mission. First, let's look at the simplest case, deploying to planetary orbit. Here, we use Kerbin as our planet. It's similar to Earth, so it works very well as a learning and planning tool. The simplest form of an orbital launch vehicle is a single-stage configuration. This means the entire vehicle is one single unit ready to fly to orbit from takeoff through ascent to low orbit. This is both inefficient and expensive for a satellite. There's really no reason to leave a heavy lift stage in orbit. It has to fly up there and hang out forever next to its satellite rather than simply returning to the ground. Rather than hauling heavy engines and fuel tanks into orbit to live forever awkwardly attached to some satellite, we will consider a more popular two-stage configuration. In this case, we use a solid rocket first stage and a liquid second stage for orbital stabilization and precision maneuvering. Using solid rocket first stage has some side effects. The most important is they burn until the fuel is gone. There is no in-flight throttle control. Throttle can be achieved by narrowing the nozzle geometry, but this is a design time decision and significantly impacts the construction cost. By using a liquid first stage, we would be able to cut the throttle on the ascent and then throttle back up at the peak of ascent, known as the apoapsis, in order to circularize our orbit for payload deployment. Then, if we've done well, we can burn retrograde, which is to slow down, and return the first stage back to the surface after deploying its satellite payload successfully. So that's just a taste of the basics of orbital mechanics. Now, we'll have more complex examples provided in subsequent episodes, so please stay tuned for those. And thanks for watching Kerbalism.